Alright, today we're going to look at probability and we're going to look at an independent case. Now, let's just say that we have 6 black and 9 white tokens. Now, I'm going to draw it twice, but after the first time, I'm going to be replacing it back. So every time you see the word replace, it means that it's independent. Okay, I'm going to show you what it means in a while. And then we're going to answer these questions after we've drawn the tree diagram to have a visual picture. So how it works is that we have 6 black and 9 white. So there are 2 colors. So at the very first part, you're going to draw a tree diagram with 2 branches. So we have black and white. So these are the 2 possible outcomes. Now, since I have 6 black and 9 white, I have a total of 15 tokens. So which means that I have 15 in total. Since I have 6 black, so this will be the probability, 6 over 15. And for the white, I have 9, so I have 9 over 15. Now, since this is an independent case, alright, I can actually reduce the probability at this point. If it's a dependent case, then I will hold off the reducing. So since this one can be reduced, 6 over 15 is actually the same as 2/5. Okay, because when you divide by 3, this is what you get. Same goes for this one, 9 over 15. I'll get it as 3/5. Now, after taking the first token, I'm going to put it back in again. So which means that I'm back to having 6 black and 9 white. No difference. So when I want to branch out the second time around, I also have the possibility of getting either a black or a white. So this is actually for the second draw. Now, because I put the black one in, I'm back to having 6. And since we can reduce it to 2/5, I'm going to write here as 2/5. And for the white, no change, it will be 3/5. Now, if I've taken white the first time around and I put it back in again, same thing. I have a choice of black or white for the second time. And same thing, since the black, there is no difference. It's as if you have 2/5. The white, you have 3/5. So this is the tree diagram that shows what will happen when we actually have 2 draws and the token is put back after the first draw. Now, so let's have a look at the question. The question says that I want the first one drawn to be white. So what's the probability of getting white the first time around? So this is the first draw to get a white. So we have probability of white is equals to 3/5. Right? So the probability of white is 3/5. And why is it 3/5? Because originally we had 9 and the total tokens is 15, but we managed to reduce it, so we got it as 3/5. So this is the first question. Now, second question is a little bit tricky. It says that the second drawn is black, given that the first is white. Now, second drawn means I only want 1 token. I'm not asking for white and then black. It's not the same. Second one drawn is black means I only want 1 token. So what they're trying to tell you is that given that the first one is white means I actually took white the first time around, but I'm not going to bother about the fact that I've taken white. It means that here I have a choice of either black or white. So the question is, what's the probability of getting a black? So I just want 1 token that is black, but it's the second time around. So this is an independent case. So it's back to as if it's at the very beginning, which is 2/5. So we have probability black is 2/5. Okay, probability black is 2/5. That's about it. So it's as if it's at the very beginning because this is an independent case. Now then let's look at the third question. No white token was drawn. So since we have no white at all, there's only one possibility, isn't it? We can only have black and black. So what we're going to write down is that we want the probability of black followed by black. And this one, you have to consider 2 of them, black and black, because you're doing twice, right? So black and black. So for the first time, to get a black, right, this is the one, 2/5. Second time around, to get black is 2/5. So since it's n, it's a multiplicative, so we have 2 over 5 times 2 over 5. So we'll be able to get it as 4 over 25. So there you have it. This is the probability of no white tokens, which is just black and black.